In this video, we will show you how to get started with the PIC32MK MCM Curiosity Pro development board using MPLAB Code Configurator. If you are new to MCC, be sure to watch our videos listed here. These videos are also linked in the description below. This project is based on the PIC32MK MCM MCU, our MIPS Core 32-bit microcontroller. For this video, we will use the PIC32MK MCM Curiosity Pro development board. Let's look at the resources available on this board before we get started. The PIC32MK MCM Curiosity Pro development board contains a PIC32MK1024 MCM100 processor, a green power indicator LED, a power diode shunt, and a power in. There's a micro USB 2.0 connector for debugging, a USB Type-C connection, USB Type-A receptacle for connectivity to PIC32 host-based applications, CAN 120 ohm terminations, an X32 32-pin interface to support audio codec, DACs, and Bluetooth radios, and users can add microelectronica clickboard functionality through the microbus sockets. There are 3 user switches helpful in reading user inputs, 2 DB9 FCAN connectors, 3 user-defined LEDs, CAN 3 and 4 header connectors, and a USB to UART bridge. The bottom assembly of the PIC32MK MCM Curiosity Pro includes an onboard debugger for programming and debugging, and a USB OTG connector for PIC32 USB OTG applications. To get started developing applications on this board, open the PIC32MK MCM Curiosity Pro development board webpage shown here and download the Getting Started demo project. The PIC32MK MCM Curiosity Getting Started ext zip file has the demo firmware, and you can extract it from there. Once extracted, open the project in MPLAB X IDE. Go to Tools, Embedded, and open the MPLAB Code Configurator. The project graph is opened, and you can see the various peripherals configured for the PIC32MK MCM microcontroller under this demo project. Clicking on a peripheral block shows you the configuration done for that peripheral. By clicking on UART 6, you can see that it's configured as UART. By clicking on the timer or TMR2 peripheral library, you can see it's configured to generate 500 milliseconds of timeout interrupt. To configure other necessary system-specific configurations like DMA, EVIC, clock, and pins, use the drop-down option available under Plugins and choose the system module you would like to configure as shown here. For example, to configure the pins, select the Pin Configuration option. In the Pin Settings tab, you can see the configurations like Switch SW1, SW2, and SW3 status change, LED1 and LED3, and other pin configurations. Similarly, to configure the clock, use the drop-down option available under Plugins and choose Clock Configuration. Here you will see the main clock is set to the default clock frequency of 120 MHz. Using MPLAB Code Configurator, you can easily add another peripheral, reconfigure the project, and generate the code. You can go to the project configuration path at any time and check the various files to understand the implementation of the project. This code sends the strings using UART on a periodic basis, and the periodic timeout can be changed by the switch 1 press. Also, the demo application prints the current room temperature periodically when the microelectronica weather clickboard is plugged into the microbus socket. To run this demo project, connect a micro USB cable between the debug USB on the board and a PC. This enables the programming of the microcontroller. Then connect a micro USB cable to the USB to UART port on the board. This provides a serial connection with the console device. In MPLAB XIDE, under Project Properties, select the target kit in the Connected Hardware Tool dropdown, then click OK. Open a terminal application, such as TerraTerm on the PC, and perform the serial port setup as seen here. You can now build your project and program the PIC32MK MCM Curiosity Pro development board by using MPLAB XIDE. Here you can see the LED toggling rate text printed on the console in a periodic basis. The periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds every time you press the switch SW1 on the PIC32MK MCM Curiosity Pro development board. The demo application has additional functionality to print the current room temperature periodically. To test the extended functionality, plug the Microelectronica Weather Click board into the microbus socket and press switch 2. More application demos on the PIC32MK MCM Curiosity Pro development board and other development boards or kits having the same part number can be found on MPLAB Discover as shown here. And finally, please feel free to visit microchip.com/harmony, where you can find out about all the features, benefits, and all other information on MPLAB Harmony version 3. We hope you enjoyed this brief demonstration. Thanks for watching.